If you care about what's out there, I mean what's really out there beyond our solar system, beyond anything we've ever been able to touch or test, you need to pay attention to what I'm about to tell you, because right now, as you and I are sitting here tonight, there is an object racing through our solar system at 130,000 dynamite. It was not born here. It was not made here. It came from another star, possibly billions of years before our own sun even existed. And in the last few weeks, it started doing something that no one predicted. It started erupting, not when it was closest to our sun, not when the heat was at its peak, 2 months later. And what it's releasing, according to NASA scientists who just published their findings days ago, is a cocktail of organic molecules, the chemical building blocks of life that have been locked inside this object for longer than our entire solar system has existed. Let me say that again so it lands properly. A visitor from another star system is spraying ancient organic chemistry across our solar system right now, and NASA just caught it on camera. Here's what you need to understand. The object is called Comet 3I Atlas. The 3I designation means it is officially the third confirmed interstellar object ever detected passing through our solar system. The first was 1I Oumuamua back in 2017, that strange cigar-shaped rock that sparked years of debate about whether it might be artificial. The second was 2I Borisov in 2019, a more traditional-looking comet, but one that clearly originated from outside our solar neighborhood. And then on July 1st, 2025, the NASA-funded Asteroid Terrestrial Impact Last Alert System, the Atlas telescope in Chile, spotted something new, a faint speck moving across the sky at an extraordinary speed. Within days, astronomers confirmed it. This was not one of ours. Its trajectory was hyperbolic. It was not orbiting the sun, it was passing through. Now subscribe to this channel right now and turn on notifications, because what I'm about to walk you through is not just the story of a comet. This is the story of what happens when the universe delivers a sealed message from another star and humanity finally has the tools to read it. Here's the timeline you need to know. 3I Atlas was discovered in July 2025, roughly 4 astronomical units from the sun. That's inside Jupiter's orbit, but still very far away. It was faint, around magnitude 17 or 18. You could not see it with your eyes. You could not see it with binoculars. You needed serious telescope power. But even at that distance, something remarkable was happening. The comet was already active. It was already outgassing. And that was the first clue that this was no ordinary rock. See, most comets in our solar system don't start venting gas and dust until they get much closer to the sun, because it takes solar radiation to heat surface ice past its sublimation point, the temperature where solid ice transforms directly into gas. But 3I Atlas was doing it early, way early. And when NASA's Swift Observatory turned its ultraviolet instruments on the comet in July and August of 2025, they detected something that had never been confirmed on an interstellar object before: water, hydroxyl gas. The ultraviolet signature of water vapor escaping from a comet was streaming off 3I Atlas at a rate of roughly 40 kilos per second. And it was doing this while still far from the sun. That's significant because it tells us this object is rich in volatile compounds: carbon dioxide, carbon monoxide, and yes, water ice. The same basic ingredients that helped make life possible on Earth. Except these ingredients didn't form here. They formed around another star, possibly in another part of the galaxy entirely. The James Webb Space Telescope confirmed this in August 2025, detecting unusually high concentrations of carbon dioxide in the comet's coma, along with trace amounts of water vapor and carbonyl sulfide. Stay with me here, because this is where the story takes a turn that no one saw coming. 3I Atlas reached perihelion, its closest approach to the sun, on October 29, 2025, passing just inside the orbit of Mars at about 1.4 astronomical units. During this time, the comet went behind the sun from Earth's perspective, making ground-based observation impossible. Astronomers had to rely on spacecraft already in the inner solar system. NASA's Parker Solar Probe observed it. ESA's Mars orbiters caught glimpses. Even the Perseverance rover on the surface of Mars paused its work to photograph the comet streaking through the Martian sky. And then, when the comet re-emerged on the other side of the sun in November 2025, something unexpected happened. Its tail was longer, its brightness was increasing, it was not behaving the way it should have been on its way out of the inner solar system. By December 2025, 3I Atlas was in full eruption. Here's why that matters. NASA's brand new SPHEREx space telescope, the spectrophotometer for the history of the universe, epic of Ryanization and ICE's Explorer, had been observing the comet since August. In those early observations, SPHEREx detected carbon dioxide and smaller amounts of carbon monoxide and water. Standard comet chemistry. Interesting, but not shocking. But the December observations, those changed everything. SPHEREx recorded a massive spike in brightness. The comet's coma, that glowing cloud of gas and dust surrounding the nucleus, was suddenly rich in organic molecules. Methanol, hydrogen cyanide, methane, and water ice was sublimating into gas at a dramatically increased rate. If you're finding this valuable, hit that like button right now, because this story is about to get significantly more complicated, and it deserves to be seen by more people. Think about what that means. This comet spent what could be millions or even billions of years drifting through interstellar space, the cold, dark void between stars. During that journey, it was bombarded by cosmic rays, high-energy particles that over geological time would have formed a hardened crust on the surface, a radiation-processed shell protecting the pristine interior. When 3I Atlas swung past our sun, the initial heat wasn't enough to penetrate that crust. The surface ices sublimated, the carbon dioxide, some water, but the deeper layers stayed sealed. It took 2 additional months for the sun's energy to penetrate deep enough to reach the ancient, untouched material beneath. Carrie Lease of the Johns Hopkins Applied Physics Laboratory, one of the lead researchers, put it this way: the comet was full-on erupting into space after its close flyby of the sun. The pristine ices below the surface were warming up and erupting, releasing chemicals that hadn't been exposed to space for billions of years. Let that sink in. We are watching material from another solar system. Material that has been sealed inside a cosmic time capsule for potentially longer than Earth has existed being released into our neighborhood, and we have the instruments to analyze it in real time. Now, let me connect some dots here, because the chemistry of 3I Atlas matters far beyond simple curiosity. The organic molecules detected, methanol, hydrogen cyanide, methane, are not rare in our own solar system. We find them in our own comets. We find them in the atmospheres of gas giants. We find them in the molecular clouds where new stars are forming. But the question scientists have been asking for decades is this: are these molecules universal? Do they show up everywhere in the galaxy, around every star in every protoplanetary disk where planets are forming? Or is our solar system special? 3I Atlas is providing the first real data point for answering that question, because the chemical fingerprint coming off this interstellar visitor looks remarkably similar to what we see in our own comets. The European Southern Observatory's Very Large Telescope had already detected cyanide gas and atomic nickel vapor from the comet back in 2025 at concentrations similar to those seen in solar system comets. Now, SPHEREx is confirming the same pattern with the deeper organic chemistry. This suggests something profound. The basic chemical recipe for building habitable worlds may not be unique to our corner of the galaxy. It may be everywhere. But here's where it gets genuinely fascinating, and I need you to stay with me, because what happens next could be the most important chapter of the 3I Atlas story. In exactly 30 days, on March 16, 2026, Comet 3I Atlas will make its closest approach to Jupiter. It will pass within 0.358 astronomical units of the gas giant. That's roughly 33 million miles. And while that might sound like a lot, in cosmic terms, that puts the comet well inside Jupiter's Hill sphere, the region of space where Jupiter's gravity dominates the sun's gravitational influence. And that matters enormously, because Jupiter's immense tidal forces could fracture the comet's nucleus. They could trigger fresh outbursts. They could crack open layers that even the sun's heat couldn't reach. If that happens, we could see material from the deepest interior of an interstellar object released for the first time in human observational history. And there's more. NASA's Juno spacecraft is still operational in orbit around Jupiter. Last year, a team led by Harvard astrophysicist Avi Loeb published a peer-reviewed paper demonstrating that it was theoretically possible to redirect Juno to intercept 3I Atlas during this Jupiter flyby using a maneuver called a Jupiter-Oberth flyby. The paper showed that with the right thrust adjustments, Juno could have come within 27 million kilometers of the comet, close enough for its instruments to provide the first close-range observations of an interstellar body. Now, whether that redirect actually happened is still being determined. Dynamicists at the Minor Planet Center are currently refining 3I Atlas's trajectory to determine whether Juno's JunoCam instrument can image the comet during the encounter. Even a low-resolution detection would provide data that no ground-based telescope can match. It would give us constraints on the nucleus size, which current estimates place somewhere between 440 meters and 5.5 kilometers across. Drop a comment right now. Tell me where you're watching from. I want to know how far this story is reaching, because this isn't just an American story. This is a human story. Here's what most people are missing about 3I Atlas. The scientific community is framing this as a farewell tour. The comet is heading outbound. It will cross Saturn's orbit by July 2026, Uranus by April 2027, Neptune by 2028, and then it's gone, back into interstellar space, never to return. But the real story isn't the departure. The real story is the legacy of data this comet is leaving behind. Between the Hubble Space Telescope, the James Webb Space Telescope, SPHEREx, the Very Large Telescope, NASA's Swift Observatory, the Parker Solar Probe, the TESS Exoplanet Survey Satellite, the Europa Clipper, the JUICE mission, Mars orbiters, and ground-based observatories on every continent, 3I Atlas is arguably the most comprehensively observed comet in human history, and the data is still coming in. NASA's TESS conducted a special observation run from January 15th through early February 2026, studying the comet's activity and rotation. The Vera Rubin Observatory captured data during its science validation observations. Auburn University researchers just published findings 2 days ago confirming the first ever detection of water production from an interstellar comet using ultraviolet spectroscopy. We are building the most complete chemical profile of an object from another star system that has ever been assembled. And every new measurement is telling us the same thing. The universe builds worlds using the same ingredients everywhere. Let me leave you with 3 things tonight. First, Comet 3I Atlas is not just a rock passing through. It is a 4-billion-year-old sealed container of pristine material from another planetary system, and it just cracked open in our backyard. The organic molecules it's releasing, methanol, cyanide, methane, are the same molecules that helped kickstart chemistry on early Earth. Finding them on an interstellar visitor suggests that the raw ingredients for life may be distributed throughout the galaxy. Second, the Jupiter encounter on March 16th could be the final and most dramatic chapter. If Jupiter's tidal forces fragment or further activate the nucleus, we may see the deepest layers of this interstellar visitor exposed for the first time. And if NASA's Juno spacecraft can capture even basic observations during the flyby, it would represent the closest humanity has ever gotten to examining something from another star. Third, and this is the bigger picture, we are living in the first generation of humans who can detect, track, and chemically analyze objects that formed around other stars as they pass through our solar system. The Atlas survey found 3I. The Vera Rubin Observatory, now fully operational, is expected to find more. We went from 0 known interstellar objects to 3 in less than a decade, and the next one could be even closer, even more revealing. The universe isn't just vast and indifferent, it's occasionally generous. It sends us samples, and for the first time we're ready to study them. Make sure you're subscribed with notifications turned on, because in 30 days when 3I Atlas reaches Jupiter, I'll be right here with the full breakdown. You don't want to miss that. I'll be watching, and so should you.